Hey everybody, this is Pete, and Happy New Year! My first video of 2021. Been crazy, but yeah, wanted to get back into the video spirit here and share an interesting kind of scenario that popped up in tech support recently where a customer had a subassembly that they were manipulating using positional representations to control it. But what ended up happening was this hinge is used in lots of different applications and lots of different attachment techniques. So they wanted to take their hinge subassembly, move it up to this upper level assembly so that they could apply different fasteners for different situations and almost treat it like a template, which I thought was a great idea. So what they wanted to do is they wanted to be able to kind of use those positional reps down below up here or manipulate the positional rep for the subassembly by the constraint. So what we are going to do is I'll just create a new positional rep to illustrate what I want to do, and we'll just say this is a 0-degree angle, and I'm going to make sure that my names match up exactly with down below. You'll see why in a little bit, but this would essentially simulate the hinge being completely closed. So what I want to do is in my 0-degree set the angle. So normally when you create a positional rep, you're changing some aspect of the design, usually some constraint. Oops. So what I would do is for example, I want to manipulate this angle to be 0 degrees, but it's not possible in the positional rep to reach inside of the subassemblies, at least not all of the relationships, and be able to manipulate them. So what I would normally do at the hinge 4 level, I actually can't do at the hinge upper level, this template level. So the next best thing in my view is even more flexible is to actually link up the positional reps. That way when I choose the positional rep in the hinge template, it will pick the corresponding positional rep down below. So to do that, I need to utilize iLogic, and I'm going to have to create a positional rep that matches every desired positional rep from the subassembly. So I'm going to go ahead and generate a bunch of new positional reps. I'll pause the video here so that we can just kind of spare a little bit of time, and then we'll talk about the iLogic rule as well. All right, so I'm back, and I've created all of the positional reps that I'm going to need. And so what I want to do now is link them via iLogic. So I'm going to come over here. I'm going to create an iLogic rule from my iLogic browser. And it's always helpful to give it a descriptive name so that you understand what this particular rule is doing. So I'm going to say positional rep linking. And I've already built this rule, so I'm just going to paste it in here, and I'll describe what this rule is accomplishing. So the first bit up here is pretty standard stuff. I'm determining which assembly template, or I'm sorry, which type of document I'm using. It's an assembly document. It's this one. I'm grabbing the component defs and all the occurrences for the assembly. And then I'm also defining an independent component occurrence for the kinds of things like I'm going to do here, where I want to cycle through an assembly and find particular occurrences of a component. And so what I'm doing is for every single occurrence in the collection of occurrences in this assembly, if that name equals this, and I realize you can rename the components. I'm going to leave it as is today, but you could name it something differently if you wish. I'm just using the customer file, so they were very gracious to share it with me. So I'll leave it there. And I'm saying if I find that particular occurrence, I want to set the active positional representation for that occurrence to equal the top level assembly positional occurrence or positional rep name. So we do that. We go ahead and save it. Never hit save and run. Always hit save and then close it. Make sure you save your document. If you're not at the master positional rep, that's okay. It'll force it to the master. And now we can test it out. Only now do I want to run the rule. So I switch it to 0-degree. Boy, that's deflating. Nothing happens. Well, what I found out is I have to run the rule in order to get that to work. So I also discovered that for whatever reason, I had to run that rule every time. So what I would suggest is I'll just drag this iLogic template out here. It seems to be I just needed to run the rule to engage it. I'll just run that rule at every single angle measure. And then once I've got that, I'm all set. So I don't know why I had to do that. I tried playing with the eye triggers. It didn't seem to help it. Maybe a wiser, older iLogic person could figure out why it wasn't running automatically. And I couldn't find an event trigger that would make it work either. So I just, because I only had a handful, it was pretty easy to run it. And then once I run it, I don't have to go back and rerun the rule. They're now linked together. So that's the solution. Now, why this is important is when I go to build a new assembly. So I build a new assembly and I'll go to place that same hinge template and we'll plop one in the origin. That's great. And then we'll even place a second copy. So why it's really powerful to use the positional reps is that I can have independent positional reps. So I can be 0, but notice it didn't impact this one. And I can change this one to a different degree measure and they can work independently. So that's an advantage versus trying to sometimes just drive things with a parameter, because if you change the parameter, it changes it everywhere. But individual subassemblies can have different settings for their positional reps. So that's why this solution works out so well. I hope you found this helpful. If you have any questions or comments, please let me know, and have a blessed day.